This video will talk about how to solve simultaneous equations, also known as systems of equations, using the elimination method. So you can solve a system using the elimination method with the following steps. Step one is to make sure your equations are in standard form. A lot of Cambridge examples already are in standard form. Elimination seems to be one of the preferred methods in a lot of the Cambridge exams, but you'll also find a lot of examples that are not in standard form. So if elimination becomes your preferred method, you might need to do some rearranging of your equations so that they are in the form ax plus by equals c. So your x and y on the same side of the equation, your constants on the other side. Then you want to look for a variable to eliminate. So this has a lot of choice and it really changes depending on the example. So it's not always eliminate x first or eliminate y first. It depends on what the coefficients are. On simpler examples, what I'm going to show today, you might find matching coefficients. So hey, both the x's have the same number in front. I'm going to eliminate that. That's not always the case. So then there's other strategies that we'll explore in other videos that you'll have to think about. But you're going to determine what would be the easiest to eliminate. And to determine that, you're looking at the coefficients. You want the coefficients in front of the same variable to either match or make easy to match. So you might have just to multiply by 2 or 3, something small to make them match. You're going to add or subtract the equations. I generally think about adding, and then if adding wouldn't work, you can always multiply an equation by -1 to change the sign, so adding will work, but I'll explain that as we go on. And then just like with substitution, once you actually do the first step, you're going to get one of the variables solved for. So you're going to get x equals 4 or y equals 8, and you can take that number and plug it back into one of your equations, and that'll solve for your final number. So step 4, you're going to get your answer, but then step 5 is always recommended, especially on exams. You can check your equation and make sure your answer works. So you plug your two numbers, your x and y, back into your two original equations, and if you get true statements, you know you've answered the question correctly. If you do not get true statements, you can check your work for small errors or retry it and see if you get something different. So let's do those steps with this example. The equations are 3x minus 4y equals 1 and 2x plus 4y equals 14. So in this case, step 1's actually done. So they're both in standard form. So I don't have to change anything. Now for step 2, I have to determine which variables to eliminate. So what I like to do is actually rewrite this. I like to line them up vertically, like when you're younger and you learn addition and subtraction. You like to line things up vertically. So what you're going to do is you're going to look at the coefficients in front of your matching variables. The x's, the top equation has a 3, the bottom equation has a 2. On the y's, we have that match. We see a -4 and a +4. And actually the fact that they're opposite signs is even better, but the fact that they match, that's what we're looking for. So the y is the one we're going to eliminate. So now that I've done that, I'm going to go ahead and actually perform addition or subtraction. So for elimination purposes, you're trying to make a 0. Okay, so you don't want to add equations if all you're going to get is bigger numbers. So if this was a positive 4x, if I add, or sorry, y, if I add 4y plus 4y, I just get 8y. So that doesn't eliminate anything, it doesn't make a 0. So I'd have to do a little bit more work. But in this case, they're already opposite signs. So adding is all I need to do. If I add a 3x and a 2x, I get 5x. And if I add a -4y and a +4y, that makes 0. So there's elimination. That's the whole point. We want one of our variables to be eliminated because then we get an equation we can actually solve. We have 1 plus 14 over here. Okay, so now I have this nice one-step equation that I can solve. I'm going to finish that out, and I get x equals 3. So that's half my answer. And now I'm going to go ahead and do step 4. Plug back in to find the other variable. You have choices. You can plug 3 in for this x or this x. I like to do equations that are all positive, so I'm going to choose the second equation. It will work if you do the first equation as well, though. So I'm going to plug in 3 for that x. And now this one's a little bit longer, but I'm going to solve this equation. So I have 6 plus 4y is equal to 14. This is a positive, so I'm going to subtract 6 from both sides. I get 4y is equal to 8. And then I'm going to go ahead and divide both sides by 4. And I get y is equal to 2. So there's my other answer. And you can write this as an ordered pair, 3, comma 2. So there's my answer. So technically I'm done, but that fifth step is always highly recommended because that lets you know that you got the right answer. So I'm going to plug in 3 and 2 for these two equations. So 3 times 3 minus 4 times 2, I want to know if that equals 1. Well, this is 9 minus 8, and yes, that equals 1. For the second equation, I'm going to plug in my 3 and my 2 to the right spots. So I want to know if 6 plus 8 equals 14. Yes, it does. So there's my quick check. You could also do this check on a calculator. It might be a little bit quicker for you, but even though technically I could type this answer in and get the points and move on, checking is always a good thing to do, especially on your assessments before you submit. And that's it. That's solving a system of equations using the elimination method.